Right, okay, the second problem I want to look at is immersion. Now, when you pour liquid into a container, the liquid will take the shape of the container that it's poured into, okay? What happens, say for example, we have this beaker and we have the liquid in it, okay? And from here to here is the level of liquid in the beaker, okay? Or the level of the volume. What happens when we immerse the stone into the liquid? Well, we know that the volume of the liquid will get displaced and the height will rise. How would we work out the volume of the object that's been immersed? Well, the volume of the immersed object will be the volume of liquid contained between the old level and the new level. So we're talking about this bit here. Okay, so the bit that's raised, so the volume of liquid between the old level and the new level will give me the volume of the immersed object. Okay, so let's take a look at an example. We're asked find the volume of a sphere of radius 2 centimeters. Okay, so that's the first part. So again, very simple. You're going to get the formula for volume of a sphere from your log tables, which is 4/3 pi r squared, and sub the information that you've been given. So in this case, we're told the radius is 2. I'm leaving my answer in terms of pi. You don't have to. So when I put this into my calculator, I end up with 32/3 pi centimeters cubed. So I know the volume of the sphere, which for the second part will come in handy. So we're told a prism with a right angle triangular cross section contains water. So this is a prism, very bad diagram, I know, but this is a right angle here. Okay. Now when we're talking about the cross section, I'm talking about the top here and the base. Okay. So these are triangles. So the cross section will be the base here and the top. So a prism with a right angle triangular cross section contains water. We are asked to find the increase in height of the water when an iron sphere of radius 2 centimeters is completely immersed in the water. Give your answer correct to 2 decimal places. Now, we already know the volume of the object that's been immersed, and we're trying to find how much did that raise the level of water. Okay, so if we take our triangular prism, okay, so this is the right angle. So say, for example, it rises in that much height. This stays the same. We know from here to here is 8 centimeters, and we know from here to here is 10 centimeters. This will be the volume of liquid that has been displaced, and this will be the height. So we're trying to find the height of the new level of water when the iron sphere is dropped into the prism. So what we need to do is we need to make the volume of the sphere equal the volume of whatever this would be. Now, this shape is a prism, so the volume of a prism will be the area of the base of the cross section times the height. Okay, so I'm just going to write the volume of the prism. Now, the base is a triangle, so it's going to be half the base times the height multiplied by the height in this case. Okay, so it's going to be half the base, which is 8, times the height, which is 10, multiplied by the height. That gives us the volume of a prism, because it's the area of the cross section, which is this bit here, times the height. Okay, so the volume of that then is going to be 40 H. When you put this into your calculator, it gives you 40. Now, we're trying to find what H is, but we know the volume of the sphere should equal this volume here. Okay, because that's the volume of water that has been displaced, and that should equal the volume of the sphere. Okay, so we're going to say then that 32/3 pi should be equal to 40 H. So how do I find H? Well, if I divide both sides by 40 and pop it into my calculator, it gives me, and it's correct, 2 decimal places, I end up with 0.84 centimeters.